So, welcome to this talk on building an Exobrain. My name is Peter. I work at Google on the Firebase team, and I am a developer relations engineer. So if you want to follow me on Twitter, that's my handle. So this talk is going to be about a problem that we all face. There is just too much information. There are so many good articles, so many good blog posts, so many good podcasts, so much information out there. There is no time to read it all. So I experience this every single day. So I go through Twitter, somebody links to something that I find interesting, but I don't have time to read it. So what am I going to do? Well, this guy would probably say, isn't there an app for that? And he's right. There are a lot of apps for this. And the most prominent one is probably Instapaper or Pocket, but there are other apps out there as well. So what's the problem? The problem is that sound is not on. Let's see. Okay, so many apps out there. And there you go. They're not invented here. So I thought, why not build an app like that myself? And you might be wondering, why? Why would he do that? And the answer to that is has many facets. So firstly, I wanted to have an app that allows me to also track information that is inside of Google. And I can't just, put stuff that's inside Google into some other people's app or cloud. Just not allowed. But if I build it in a system that runs inside of Google, that might be a different story. The other thing is, in my job as a developer relations engineer, I need to understand the tools that we have in order to be able to find out, are they working well? Or to explain them to you. Or to tell the engineers, well, actually, something's missing, something's not working well, something needs to be added. So these are some of the reasons why I built this. And in this demo here, you already saw the application. So what you can do is, if you are in Safari or in Chrome, you can use the share sheet, send your article into the application, and the application will store it. It will extract a readable version of the text, store it in Firebase, and then extract some metadata so that you can later search that metadata and read the simplified version of the article instead of the version of the article that has all the ads in it or extra formatting. And then it has some additional features like summarizing or Q&A. And we'll talk about that later on. So when I first built the application, I did not envision that we'd be talking about AI so much. So originally, it was really just an application for reading something later. But then late last year, when OpenAI released ChatGPT and people started implementing stuff with it, I thought, OK, let's try it out. So the first version of that app used OpenAI's GPT to summarize articles. And as you might know, Google has their own large language model. It's called PaLM, which stands for Pathways Language Model. So now this application uses that model to do all the AI stuff. And we'll talk about how that works today. So there are a couple of things I want to walk you through. The first is we'll talk a little bit about architecture. How do you build an application like that? Then we'll look at how to apply that architecture for storing cleaned up articles for offline reading. Then we'll look at how to summarize articles. And finally, I'll show you how to implement Q&A so you can talk to your knowledge base. So, architecture. So the first thing that you face when you think about building an application is, where should I put the business logic? Should I put it on the client or should I put it on the server? I don't know about you, but I feel like this poor guy a lot of times. So What are the advantages of doing this on the client? Well, the first advantage is that you can use a language that you are familiar with. So I am an iOS developer. I know it sounds weird because I work at Google. A lot of people say, what? You work at Google? You've got an iPhone? Yes. On both counts. Yes, it's allowed. And if you go to the App Store, Google is one of the biggest developers on the App Store. Count the Google apps. There are dozens of Google apps. And we've got hundreds of iOS engineers at Google. So for me, it's easy to use Swift as a language, right? So it feels natural. It's like talking in German. It's a lot easier for me to talk in German because it's my native language. You can use the APIs, you know, right? So you already probably use URL session to fetch data from the internet. So you can use that, those APIs to talk to any other pieces that you might need to talk to. There is no need to operate servers, which is great, right? No need to buy anything, no need to set up anything, no need to manage them, no need to keep them up to date, no need to plug any security holes. And you can do everything yourself. So if you're an indie developer, you probably can get started alone or with a small team. That's great. But then you realize, oh my God, my application is so successful, everybody wants to use it. And they might not be on iOS, they might be on Android, or they might be on the web. And in this particular case, for this application, the web is a centerpiece of the application, right? Because you might be on your desktop computer and you run into an article that you want to read later, so you want to save it into the app. So you need to have some sort of bookmarklet, for example, or a plugin or extension for your browser. So, and that leads to a lot of duplication if you implement the code client-side. You'll have to do it over and over and over again. It's not great. But there is a solution. Let's put something on a server, but actually let's not use a server. Let's use a serverless architecture. So this might be something that you might want to use. So you've already got Firebase. You already store stuff in Firebase and use some of the services. And now you want to implement custom functionality. One way to do that is to use a custom backend implemented in Node, for example, or in Ruby. You can talk to the Firebase services. That's all fine. But we want to use something which is native to the platform. And thankfully, there is Cloud Functions. Who here has heard about Cloud Functions? Show of hands. Amazing. See, that's the difference when you talk to a Google audience, right? Most people know the stuff that Google has. So Cloud Functions are a serverless environment, essentially. So they allow you to implement functionality on the back end. And it's not a secret. It does run on a server. It's just, we manage that for you, so you don't have to do that. And because we manage that in virtual environments, it means that we can automatically scale to your needs, right? So if your application is super successful, you get a lot of people, and it's ramping up. I don't know, maybe it's the #1 launch on Hacker News, for example, and people see your app and then, oh, they want to try it out. You need to scale your backend, right? And we can do that for you if you use Cloud Functions. It's also a trusted environment. So what does that mean? If you have secret information, for example, an API key, so you need to talk to a backend system, and that backend system has an API key that you need to use in order to talk to it. You put your API key in your app. So let's assume for a moment that we do that on the client. So we put our API key in the client. What's the problem? The problem is anybody can download your app. I mean, they download the app to their phones, but they can download the app to their computer and then just exfiltrate your API key. Probably just open the binary in the hex editor, search for a string, and they will be able to find your API key. And they can do that because the phone is not a trusted environment. You have no control over the user's phone. But a server is considered a trusted environment because it is in a secure environment, it is in a data center. It's extremely difficult to break into a data center physically. It's very difficult to break into a data center digitally. So it would be extremely difficult to get into your application and extract that API key. And that is why we call Cloud Functions a trusted environment. The languages that you can use are TypeScript and JavaScript. And new as of a couple of months ago, we also support Python, which is pretty amazing because a lot of the stuff that we do in AI and ML uses Python. When I go to iOS conferences, I always ask people, would you like to see support for Swift as well? So for anyone who's interested in getting support for Swift, for Cloud Functions, here is a QR code that you can scan, and then you can vote for that. Even if you're not a Swift developer, you can go to firebase.uservoice.com if you have any feature requests for Firebase. So that's a system that our product managers use in order to find out what the community needs. So use that QR code or the URL to go there and make your voice be heard. OK, so now we've got our Cloud Function in the backend. How can we call them? Because our application is still running on the user's device. There are two main ways how we can do that. The first one is using HTTPS, and the other one is so-called callable. So HTTPS is just a regular HTTPS endpoint, and you can call it using curl or just a plain URL request. It's like a regular endpoint. Callable functions are slightly different. In addition to getting the input parameters and sending you a response back, they also have access to the context, and the context contains information about the user who is signed in on your phone. Scheduled functions and queue functions are another way to run your Cloud Functions, and that might be useful if you want to run something on a regular basis. For example, it's the end of the year and you want to send all your users an email saying, oh, you did well, you stored like 1,000 articles and you read 10 of them. Amazing job, maybe do better next year. So that's something that you could do. Or run backups, or if you've got huge chunks of data you want to process, then maybe you want to do that in a queue. And then one of the most amazing things about Cloud Functions for Firebase is so-called triggers. So Firebase has a lot of products, and probably the most well-known ones are Cloud Firestore, or the real-time database, Firebase Auth, or Crashlytics. So you can write Cloud Functions that respond to events that are happening in your application. So for example, if a user signs up, you can run a Cloud Function, and you can run this Cloud Function to send them an email saying, welcome to this application. Or maybe you want to do something when the user stores a new document, right? So in our case, when the user stores a new document into Firestore, we want to run a function that downloads the URL and simplifies the text. But there is more triggers, and here's just a small selection of them. So that is a really, really good way to enhance your application whenever something interesting happens. OK, that was architecture. Now let's apply this. So here on the left-hand side, you see an article from the New Yorker, and that is how it's rendered in the browser. So here it's in Safari, and it's beautiful, right? Nice font, it looks great, but also the information density is not very high. And it might have ads, for example, so that is a little bit annoying. And on the right-hand side, you see the same article, but it's simplified. We see the hero image, we see the title, we see where it's from, and we see the first paragraph of the text. It's already a lot better. It's already a lot more readable. Plus, what you can't see here, the right-hand version is offline capable. So you could read it on the phone, or if you are in a tunnel, or I don't know, maybe your data plan has run out. So that's another advantage. So let's look at the architecture for this. So on the bottom, you've got the client. So let's assume the client wants to, or the user wants to add a new article. So what they do is they send this article to the application. The application then stores it in Cloud Firestore as a document. That triggers an onCreate function, and that function will then go off to the website and download the URL and the text that's behind it, get it back, simplify it, get the metadata, and store all of this information back into Firestore. And because Firestore is real-time capable, the client will get an update almost instantaneously. So I've talked about Firestore quite a bit, so let's look at what Firestore is. And here are some of the features that make Firestore unique. One is it has effortless syncing. So let's assume you've got a to-do list application and you add all your to-dos. You might want to see all those to-dos on your phone, on your computer, on your tablet. But you might also want to see those to-dos. You might want to share them with your family or with your coworkers. And Firestore makes that really easy because it synchronizes this data that's in Firestore to all the client applications that are attached to it. It is offline first, and that means when you add something to your Firestore instance and you're not connected to the internet, it will store it locally. Once you get online again, it will store it. It will upload the change into Firestore. Same if somebody has made a change in Firestore, you come off online again, you will get that change. If you don't want to do real-time sync, you can do one-time fetches as well. That's useful if you have bigger chunks of data that you want to download. Data in Firestore is stored in documents, and here we see a couple of documents. So a document is like a JSON structure, essentially. You can store all sorts of data in it, strings, integers, arrays. And those documents are then organized in collections. And you can think of a collection somewhat as a folder, similar to a folder on your computer, right? So in a folder you can have multiple documents, and then you can nest them. And the way how nesting works in Firestore is that a document can contain a subfolder, a subcollection, sorry, and that subcollection contains documents, and each of those documents can contain subcollections again. So it's always document, collection, document, collection, right? You can never put a document into another document or a collection into another collection. It always has to be alternating. And here is how it looks like. So on the left-hand side, you see a collection of articles, or it's the list of collections. That's a way to put it. In the middle column, we see all the documents that are in this collection. And then on the right-hand side, you see one specific article, the one that I've selected. So that is one of the documents. And it's got a number of attributes. So let's look at how those attributes map to your source code. So here we see a struct, which is a data class in Swift. And you can see how the individual fields map to your document on the right-hand side. So we've got an ID, and that ID maps to the document ID, which is a unique identifier. And then we see how the excerpt attribute maps to this excerpt field in the document. Adding stuff to Firestore is pretty straightforward. So here we can see how we would add a document. So you make a call to add document, and you pass in an instance of this document struct. The good thing is that you don't have to do the mapping manually. So in the past, you would have to go in and say, okay, so I have data class, which is a Swift type, and I need to go over all the attributes. I need to map them to JSON or into a dictionary and then pass the dictionary into Firestore. All of that is no longer necessary. You can just take it as it is. We will do the heavy lifting for you and do the mapping. Articles is the collection path that we'll be using, and it's a top-level collection. If I wanted to store it in a nested collection, you could, write a path, and separate the individual pieces of the path using slashes. But here, it's a top-level collection. And then when you add the document, you get document reference back, and you can use that document reference to, for example, later on make changes to that document. Okay, so what happens if we store that document into Firestore and we want to operate on it? And here you can see the 4 basic kinds of triggers that you can use to operate on a document in Firestore. You can run a trigger when the document is created, or when it's updated or deleted, or write is a general write, so creating, updating, or deleting. And then this context parameter here gives you access to detailed information about the user. So for example, you can say, who is the user who is currently signed in? What's their name? Do they have an email or a profile picture, and so on and so forth. But really, the thing that's most important is the UID, and that's the unique user ID of that user in your application. And you can use that to write it into the document and say, okay, this document, this piece of data belongs to that user. Cool, so let's look at how to write a Cloud function that downloads the cleaned up HTML and stores it back into Firestore. So here we say we want to listen to any changes on the artifacts collection where we have a document, and we want to also, carry along this document ID so that we can use that document ID for doing stuff with it. And specifically, I want to run this function whenever a new document is created. So I don't care about updates. I want to run this when it's created, right? Because when the user stores something, then we want to download the simplified HTML. Here we get a document snapshot, and that is the state of the document as it is written into the database. So all the fields are in there. Usually that would just be the URL. And then we can take that URL and then use a utility function that downloads this URL, parses it, and gives us a simplified version. I'm using the Mercury parser. That is the same parser that Apple uses in Safari when you go into reader mode. So now we've got our simplified HTML, and we want to store it back. So the first thing that we do is we get the entire document as an artifact document. So this code here is TypeScript, and that is why we can deal with it in a type-safe way. And then we get the readable HTML from the Mercury parser and store it into that document. And then we use the reference and update the document in Firestore using this updated document. And that's it. All right, so now we've got our cleaned up HTML stored in Firestore. Let's take a look at summarizing articles. So here you see a demo. I've got an article that is pretty long. I don't have time to read it, so I open the Notes tab and then tap on the magic wand, and that will go off and create a summary for me. Right? Usually I would go in and type it myself, but this thing does it automatically. So how is this implemented? Here is the architecture that you saw before, and now we want to do something differently. So instead of talking to the database, we already have the article in the UI. So we can now go to a Cloud function and tell that Cloud function, listen, here is an article. Please give me a summary of that article. That Cloud function will then go off. In this case, it goes to the PaLM API. The PaLM API will produce a summary using its LLM, hand it back to the Cloud function, and then the Cloud function sends it back to the client. Why didn't I store it back into the database in the first place, right? Or why didn't I produce the summary when I stored it into the database? You could totally do that. The reason why I didn't do it is those LLMs are expensive, right? So making a lot of calls will create quite some bill for you, and you might not want to do that for all of your users. So let's assume that you ship your application to the world, and a lot of people are trying it out, but not everybody is convinced. You know, maybe they are like me, and they think like, oh, it's not invented here. I'm going to try a couple of applications before I settle on one. And you know, they're trying it out, so they're not buying your application yet. And for them, you might not want to provide this functionality out of the box. So you might only want to provide this functionality for people who pay for your app. Or maybe you want to give everybody maybe 10 summarizations for free, and then the 11th one they need to pay for. And that is why you want to do that on the client, because there you can look into your subscription data and say, okay, this user has subscribed, they're good to go. And then finally, you write that back into the database. So I mentioned before that there are two ways to call a Cloud function directly from your app. And here you can see it a lot better because the onRequest call takes a request and a response. And that is literally what you would normally do when you write a HTTPS server, right? If you write your server using JavaScript, whatever, you get a request, you get a response, and then you send the response back to the response. The second call, onCall, that gets data and the context. So the context, again, has information about the user. The data object, that is a parsed version of everything that's in the header and the parameters. So again, makes it a lot easier for you to deal with this data. Yep, so here again, you can use the context. So here is the function to produce the summarization. It's a callable function. That means we can call it directly from the client. This is the name that it will be registered with. And here is the remote API that we want to call. So this is a call to the PaLM LLM model. And of course, we need to give it a prompt. And this prompt is pretty simple. It says, summarize this article, and then I'll just give it a URL. So I could either give it a URL or the entire text of the article that's behind the URL, so the simplified version. So if I give it that URL, it either means, or that only works if the model either knows all relevant URLs, and that's relevant in terms of the cutoff date of the LLM, or it is capable of downloading information from the internet. Okay, so now we get data back from the LLM. We parse that result and send it back to the client. So how can we call a Cloud function from the client? Here is how you do that in Swift. So first of all, you need to provide the name of the callable function. Then you need to tell it what are the input and output parameters. This here enables call as function, which is a very nifty feature of Swift, which enables you to define a class and then say, well, this very specific method on the class, I want to call that as a function without ever having to instantiate the class. And this is why this call here actually works. So it looks like a freestanding function, but really it is a function on an object. Okay, and this is how we implemented summarizing articles. Now, let's rack it up a notch and talk about Q&A with your knowledge base. Again, here's a demo. So here's an article. It talks about Swift macros. I have no time to read it, so I go back and I go into this chat feature and I talk to my application and I ask, what are Swift macros? So it will go off and find all the documents in my knowledge base that are relevant to this query, get them back, and then try to answer the question. So this is not going out to the internet. This is answering just using the articles that I stored in this database. And I can, the answer I get back is pretty good. So it's, what you see there is actually the case. Okay, so let's look at how we would implement that. And again, here's our architecture that you are already familiar with, but now we need something more because we need to store vectors, vector embeddings. Who has heard about vector embeddings before? All right, quite a few of you. So don't worry, I'll explain what they are in a moment. But you should know that at the moment, you can't store vector embeddings in Firestore. We need something else. So here we need the PaLM API. We used that in the previous example as well. And we need Cloud SQL. Cloud SQL is a feature, it's a feature of Google Cloud. And you can use it to run a SQL database. And in this very case here, I'm running a Postgres database with the PG vector extension. And that allows me to store vector embeddings. So when I store a document into Firestore, I will have a function which goes off, talks to the PaLM API and says, hey, here is a document. Can you please compute vector embeddings for this document? And then give them back to me, and that the function will take those vector embeddings and store them in the Postgres database with PG vector. So what are vector embeddings? So let's take a step back. Assume that we have the task to find all words that are food in the following sentence. So the sentence goes like this. I went down to Aberystwyth on foot to buy some Welsh cakes and a few berries. When I finished doing my groceries, I had a latte at coffee number 1, where I met a few other speakers. So, that was from the previous time when I gave this talk in Wales. So for you, as a human, it's easy to find all the words that are food, right? So Welsh cakes, berries, and latte. Those are pieces of food. The berry in Aberystwyth is not food. Foot sounds like food, but is not food. Groceries, in this case, is not food, but it's the activity of buying stuff. And coffee in coffee number 1 is not a drink, but it's the name of the shop. So for you, it's easy, but for a computer, it's not. So we need to tell the computer how to reason about words. And a vector embedding is a mechanism that can help us with that. So a vector embedding is a numerical representation of a word, a sentence, or any other unit of text. So here is the vector embedding for food. And I've shortened it because it literally has a couple more hundred values in there. So a vector embedding essentially is an array of floats between -1 and +1. And here is the vector embedding for foot. And if you don't even have to look closely. If you look at it, you'll see it's different. So for a computer, it's super obvious that those two words are different. And we can use that fact to then start reasoning about it. So who here knows what this is? Yeah, go ahead. Yeah, it has to do with correlation, but look at the two numbers. Almost. So it's not Berlin as GPS coordinates, it is London. But pretty close, right? So, and here are vector embedding, or sorry, here are the coordinates for a couple of other cities, and you can see them on the map. So for us, looking at the map, it's easy to tell, well, London and Paris are pretty close to each other, but London is pretty far away from New York, for example. And using those vector embeddings, or those coordinates here, which are vectors, right? A coordinate on a coordinate system is a vector. If you remember your maths, you will remember, okay, so we've got the coordinate system, there is the 0 point, and then I've got an arrow pointing to a coordinate on that. That's a vector. If you look at the coordinates for Paris and London, for example, you can see that those numbers are pretty close. And you can also see that the numbers for Paris and New York are a lot more different. So, you can tell that they are further away. And for a computer, it's even easier because you can use math to tell how far away or how close they are. And there is, the mechanism that we use for doing that is cosine similarity. So you use that to compute how similar two vectors are. So, and that is what we use to tell how words are different or similar. So, how does this relate to our Q&A engine? So, when we store a document into the database, we want to compute a vector embedding. So we run this function here, and you might be able to tell that this is a Python function. And this Python function will run every time that a document at this path is updated. Here is the artifact ID, the document ID. And the name of the function is compute embeddings. And here is where we get the document, so it contains all the fields in the document. So we take the document snapshot, we extract the URL, and then we take the artifact ID, and then we call another function to compute the embeddings for the text behind this URL. So here's how it works like. First, we call another function which will chunk the text into smaller pieces. Why is that important? LLMs can only operate on a certain number of tokens. So token, might be a word, might be more than a word, but roughly a word. So if you have an LLM that can operate on 4,000 tokens, that might be maybe a page or two worth of text. But if you have an article that's a lot longer, then you can't ask the LLM about it. So you need to slice it into smaller pieces, and that's what we do here. So we slice it into smaller pieces, then we connect to our vector store, to our SQL database, and then we tell it to add those documents to the database, and we use LangChain to compute the embeddings and then store them into the SQL database. So how does it work? We store, and this is how you store, but now we need to retrieve. So retrieving is when the user asks a question. So we've got all those embeddings in the database. Now the user asks a question. We compute the vector embedding for the question. Then we go to the database to retrieve all the documents that are similar enough. And then we take that, go to the large language model and tell it, okay, so here's all the context. Please, can you answer the user's question just using the context? And here's how this function looks like. So here you see a pretty big prompt. So it's an on-call function that we call whenever we are in this chat window. We get the query from the request. We give it a prompt, inject a couple of variables into the prompt, connect to the vector store, retrieve all the relevant documents, and then run this LangChain chain to perform the Q&A using our large language model. So that will get the documents, feed them into the prompt, and then give the user an answer. All right, so that is how you do Q&A with your knowledge base. And there is one more thing. Okay. Let's see. Okay, so here is my phone. Talk to my knowledge base. What is the difference between freestanding and attached macros in Swift? And here's the answer. And this is fetched from my database, not from the internet. So I was able to connect Siri with my application, and here is how you do that. So you implement a Siri app intent, and because we are already at the end of the time, let's go to this final piece. So I fetch data from there, and then I render it as a markdown into a Siri intent so that it gets this beautiful formatting. And this is a wonderful library that allows you to render markdown in the SwiftUI application. All right, and that was how I used Siri, PaLM, LangChain, and Firebase to create an Exobrain.